Good. Well, thank you very much, everyone. What I thought we better do today to start things off is refocus things a little bit, and with emphasis on just covering what was happening in the blueberry fields with this year's drought stress, and just go over what some of the implications are with respect to this upcoming season. So I'll keep an eye on the time, but I thought this would be first and foremost the top priority. And then after that, we can give a little bit of insight into some of the research activities we have underway, including the remote sensing, including the use of the drones, some nutrient management updates. We've just finished a project in that regard, as well as some changes that are happening with respect to disease management and other pesticide management work as well. And then also work Emily Kirkpatrick has underway with respect to looking at the production footprint that's associated with wild blueberry production. So we have a team of approximately 10 folks working on our research activities this past field season. It was quite a challenging field season, just given the drought stress that was incurred. But we do have Dr. Ola Papula, who's here, who was leading the remote sensing work. We have Naomi, who was looking after some integrated disease management with emphasis on the botrytis blight. And as I mentioned, Emily and her work on sustainability analysis. And then we also had Callie Emiker working on the fruit ripening process in the blueberries as well. So when it comes time then to describe this field season, other than a nightmare, looking at the rainfall patterns, this is where it starts to get quite interesting. And so breaking it down into looking what happened from June through till the end of October, rainfall for the months of June through September were on a month-by-month basis at least a quarter of what was normally received. So really scant amount of rainfall, so 37 mils for all of June, 28 for all of July, another 28 for August, 29 for September, and then things really did not begin to pick up until the end of October. So it was around the 27th and the 31st, where we finally started getting some significant amounts of rainfall. And this is out of the weather station we had at the research station, and I thought I also better just verify it with the Environment Canada website, or station at the airport. So looking back then, trying to provide you with a bit of an understanding then of, well, how does this plant respond and interact with drought stress? It actually was what I started off with, one of the main research areas when I started work here all those years ago in the mid-90s. And the chamber system that was used continues to be used. It's one that's seen a lot of use with other cropping systems, but it really provided us with insight on how the plant responds to drought stress. And going over it in just trying to hit the highlights. What we did was we put in some containerized blueberry plants into that controlled environment, carefully tracked what was going on in that chamber environment over the course of the better part of a week. And in this particular trial, just giving you a little bit of insight, what these yellow bands refer to are the day length periods over the progression of that 5 days. So over 5 days, what we had is two different scenarios. One in which the plants were watered on a daily basis, and that's the top line, and then where we just let them dry out over the course of a week. And we looked at volumetric soil moisture levels. So over time, what happens is the plant dries out, as you'd expect. We had a look at the relative water content and what happens with plants that were watered daily compared to those that are exposed to stress. And then more importantly, we looked then at how are these plants using water, and then also what's happening with their ability to make sugars to support plant growth and development, because that's over 80% of the plant's dry weight is very much then dependent on the ability of the plant to use the light energy and make the carbohydrates. So some key things that we observed right out of the block was, first off, the plant is incredibly resilient to drought stress. So going back to the field, as long as you have a green functional canopy, plant's going to be in decent shape. Once you lose that green pigmentation, in other words, the pigments start to break down, that's when you really do have a problem. And I'll come back to this throughout the course of the presentation. The red line in the what I call the stem water potential, this line here, is a benchmark. And the best way to look at it is kind of similar as taking, pressure gauge reading on your tires. So, you start to get really concerned when you're underneath 30 pounds. Well, in the case of these stem water potentials, once you get below minus 1.5, this for a lot of crops is what's considered the point of being a permanent wilting point. So there's going to be significant damage to the blueberry. But in our case, blueberry plants do quite well. They can take a tremendous amount of drought stress, and yet they'll still effectively photosynthesize. So even in this environment where we withheld water, the drought stress levels were phenomenal, like really, really low, like underneath underneath 3 megapascals. That's just a tremendous amount of stress. There's not too many temperate plants that can take that sort of level of drought stress, but the blueberries can do reasonably well with respect to still being able to make carbohydrates. The weakness, or one of the problems, is the plants are not as good at conserving moisture. Okay, so they're still going to use water. And that's one of the aspects that eventually then catches up to the blueberry plants as well. And so in the work that was done up to 2000, then what we did is we also had controlled trials out at DeBert where we had water exclusion shelters. And we said, okay, well, what is it that's changing in response to plants as you expose them to drought stress? And what can you key in on to try to give you appreciation then of what to expect going into the cropping year? And overall, what we found is the thing you really need to focus on are the floral buds. Okay, so it doesn't really matter so much as how tall the stems are, the girth of them, the fruit zone length, and the other parameters that we measured there. It really comes down to the number of floral buds that are present on a stem, and then also the stem density. So at this time of year, really the first thing to key in and focus on is what's going on with those floral buds. Okay, and the top is where we exposed just one season of drought stress, and the bottom was where we exposed it to 2. And in both case scenarios, it comes down to those floral bud numbers. Now, what was interesting at this point in time of work as well, it was kind of like going back through memory lane when I was having a look at the work for this talk. We had quite a few students that were working on the drought stress. So Vimy Glass worked on it, followed by Angela Murray. And at the same time, there was work on some of the native grass species. And could we use them in bare areas, to try to stop that erosion that was occurring and the receding of the canopy. And at that particular point in time, we thought some of that was occurring as a result of Velpar. So we paid fairly careful attention to the partitioning that was occurring. So in other words, what's in the stems versus the roots versus the rhizomes. And it was Corinne that actually looked at the effect of some of these native weed species and what was happening. And then Klaus Jensen, the Canada weed scientist at the time, he even proceeded to get as far as having a look at some of these native grass species. And I think he did 1 or 2 seasons of hydroseeding some of these grass species just to see if they would hold the bare area, but it came down to being just a little bit too cost prohibitive. But this was some of the work that we did out at the research station in DeBert, where we kept fairly detailed logs of what was happening with respect to soil moisture. And again, what we did is we excluded water for the entire growing season from some of these treatments. And we not only had shelters over them, but in some of the treatments, we even edged around them. And then what that ensured was that there would be no lateral movement of water, from a untreated area into the drought stress plots. And we logged the soil moisture content and other parameters over the course of the growing seasons. So we looked, as I mentioned earlier, about how the plants use the light energy. And they're incredibly resilient with that perspective. So they can hold their own with respect to being able to use the light energy and make a carbohydrate. We looked at this with some in-field photosynthetic measurements. We also used the same instruments to measure water loss, so transpirational flow of water that was occurring. And over the course of the experiments, what we found out is looking at the volumetric soil moisture out in the DeBert site, where the exclusion shelters were used, water levels are really, really low. So we were able to really impose on them some pretty significant levels of drought stress. And then with respect to the implications, as long as the water was there, the blueberries are going to use them. But they are a plant that doesn't conserve moisture. So in other words, it won't try to conserve what resources it has. It's just going to use it until it loses it as far as water use is concerned. So we didn't even find much of an effect of excluding the moisture from the plots in this case. We did see the plant's ability to make sugars. It was diminished where we excluded the moisture. And on the photosynthesis side, what I'll also mention is we start to see some separation. And what this lighter bottom line is where we actually edge the plot. So this was a drought stress treatment. And where the water wasn't able to move in from adjacent areas, the photosynthetic rate started to drop off. So in that scenario, what we began to see is over the course of a growing season, the plant just can't make enough carbohydrates to keep and support its growth and development. So hopefully with this, and I've got some other photos that'll back this up, the plant is an incredibly drought stress and resilient plant. The photosynthetic activity, so the ability to make those sugars, I think they're going to continue as long as that canopy's dry and it has some soil water available to it. It can take a tremendous amount of stress. But the plant is not an efficient user of water, and there'll always be a little bit of leakage. And that's one of the downsides of dealing with many fruit crops and not only blueberries. And so eventually, this is going to cause the photosynthetic activities to drop off. And so what we started to see this particular year with some of the trials that we had out is where we had untreated areas, in particular those that had both the hair as well as the red fescue fill in afterwards. You could see by the middle of July there were some definitely some treatment effects on the water content within those plots compared to where we were able to keep the fescues out. In particular, the red fescue, because it's rhizotomous, it gets right in with the rhizomes and the root system situated within the blueberry. And the reality is they just can't compete with the blueberry in that or the blueberries just can't compete with them. And when I initially saw this was some of the work that Corinne did. I said, well, it kind of looks like Pac-Man, but actually what it is, it's a cross section of a red fescue leaf. And what you see is this is the upper side of the blade. There's actually some trichomes situated within it. So it's a very, very efficient leaf structure when you look at exposing it to drought stress. It's going to conserve its water far better than the blueberry leaves will. And this is one of the reasons why if you go to areas such as Southern Europe or other hotter, drier climates, what's one of the main weed issues that's facing the grape and wine sector? It's red fescue. Okay, so it's really adapted at conserving moisture and being incredibly competitive. So it's one that unfortunately will do better than the blueberry plant in the fields. And so what I thought I'd better do, given we had the plots to work with, was to take the pressure bomb out, which measures the plant water content, have a look at the blueberry stems, and where we, got ahead of myself, where we have the presence of these fescues. So starting in June, and this was just a couple of miles up the road from where I lived, even at that particular point in time, you got a stem water potential of minus 2.8 megapascals. That's a lot of drought stress. And then followed a month later, it was up over minus 3. And that's just an incredible amount of drought stress. So it really provides insight into the level of stress these plants, blueberry plants, which had the fescues intermingled with them, were under. We were able to keep things relatively clean, wasn't anywhere near as bad. So it really just conveyed the competitive pressures these grasses can pose to the blueberry when you're looking at water usage. Some other things that we noticed over the course of the season were, especially in the crop year plants, as long as you could keep the canopy healthy, the plants kept their leaf gas exchange rates up, and the plants were doing quite well. And what you can notice is anywhere where we didn't have a fungicide treated, you started to see some chlorosis and then eventually some leaf drop occurring, which is the case here versus here's where we actually had some of the fungicide treatment applications for botrytis and other diseases occurring. So again, from a leaf disease perspective, as long as you could keep the plants relatively healthy, we found that over the course of the season, they did a little bit better. Now, as was mentioned earlier, another thing which showed up, and we've seen this in prior years, so the first year that I can recall seeing it was around 2006 or 2007. And this is where we had stem blight. And at the time, it was identified as Phomopsis stem blight occurring, which is caused by a fungus. Now, upon looking at the conditions, this particular, this year, I'm not convinced it's due in its entirety to that. And it's just when you look at the symptoms, it almost appeared as though the whole shoot upright was adversely affected. And you could, even if you tracked it down below that, it looked like it was originating from the rhizome. So what we are wondering is if in the quest for water, if some organisms didn't get sucked up into that rhizome, and then cause subsequent issues which appear like a Phomopsis blight. But they were quite noticeable across the province. And, in a square meter, you might have 400-600 stems. Well, there weren't too many fields where you didn't find at least a few of those present. So quite problematic from that perspective as well. So it's something that to be aware of and one that we're continuing to monitor. So by the end of August, we were starting to see some pretty substantive differences with respect to how the blueberries present in the fields were responding to drought stress. And something that I really didn't expect to see was where the velvet leaf blueberries, so the myrtleoides, was actually in worse shape than the sweet lowbush blueberry. And so the myrtleoides, it's this purple-colored one situated here with the hairy pubescent stems. If we came back, this was in, I believe it was late August, early September. It came in 2 weeks, leaves are completely gone, right? So there was quite a bit of difference with respect to how the species were responding to the drought stress. And if you followed those through and looked at the number of floral buds, they wouldn't be there. There just wasn't enough to support the ongoing growth and development of those floral buds in the myrtleoides. And this is something that when you looked at the phenotypes, we continue to see this also. So this is a trial that was done up in Lynn Mountain. And this was, I think, around the 24th-ish of August. And at a particular point in time, fields are under just an incredible amount of stress. And the upper part of the canopy was just crimson as a result of the drought stress. And this is what we saw as far as the fruit, and this is no surprise with respect to what was being seen across the province, but it is important to note. Because when you look at, okay, well, what's going to lose the water the quickest in the crop year? It's undoubtedly the crop. And so you see this shriveling up, the raisioning effect that was occurring in the berries. And I'm going to come back and we'll talk about this in a few minutes of ways to try to potentially slow that down. Right? So hopefully no surprises as far as what was observed so far. But what was a surprise was when you look then at some of the clones or phenotypes present in the field, it was really quite amazing that you could have one, like this example over here, where it's an Augustifolium clone, still quite green, functional nicely. And then over in this area, it's a clone that's just fried. It's not only a matter that the leaves have lost the chlorophyll, but they're boarding as well. So they're shedding. And so the question becomes, okay, what's going to happen to that clone this upcoming season? Hopefully there's enough carbohydrates that'll be able to spring back in the spring and form some new shoot uprights. But it's quite a substantive amount of stress to be placed under. And some other things that we saw, just looking at things this past week, or then when I was looking out at some of the fields, what I mentioned earlier, it really does come down to having a look at those floral buds. They're your best tool with respect to trying to gain an appreciation of what's going on. So the signal to form those floral buds starts to be perceived by the blueberry plants in mid-July or so, mid-end of July, and that's what we call the induction process. The initiation is when the floral buds start to form, and that's a process that hopefully starts in mid-July, continues well through the fall. But again, we didn't have a lot of rain through until the end of October. And as a result of this, did the plant have much as far as the name of resources to put in those buds? Not a lot. But the good news is at least there's some floral buds out there. And then looking at things across the province, at least canopy in many blueberry fields held up. And so looking at things going into next year, first priority is have a look at the floral buds. Second thing is go out and sample. And even as early as the end of February, you can go out and sample the blueberry stems, and you'll have a fairly good idea then when you sample the stems, bring them inside, and you can force the buds, see what's there as far as floral numbers. That'll allow you to gain a little bit of insight. But it is a concern going into winter, just how much is there to help support those developing floral buds. And so we have some scenarios like on the your left-hand side there, where floral bud numbers, you might have one per shoot, really quite small, not well developed. Something to keep an eye on. In this scenario where, you hardly would know that you had a drought stress. You have 5, 6, 7 floral buds per stem. So all is looking reasonable as far as that's concerned, and then everything in between. So it really is, there's a lot of variability in fields with respect to the number of floral buds. So encourage you to have a look at it over the course of the season. Okay, and that just gives you a bit of an example of the variability that you can see this time of year. So looking at things, and this is where it was good to talk to some producers that have seen it before. You'd have to go all the way back, I think, to they said around 1968 to see something that was even anywhere close to the severity of drought stress that we had this year. As I mentioned, the signal has been sent with respect to the floral buds. And so the floral bud process that's going to occur and be present for next year, it started. Now, there's still time. So the plants hopefully can get through the winter without too much. Hopefully, the last thing we need is a polar vortex or something along that lines to come along. But hopefully we can get them through. And then there'll still be time for those sets, for the cells in the floral buds to keep developing, swelling, and hopefully provide a good crop going into next year. The other thing I just wanted to mention is, as you'd expect then, the presence of other biotic pressures, whether it be some of the leaf spot diseases or the grasses, they really created issues with respect to the floral buds. And important thing, as I mentioned, just keep an eye on those floral buds. Best tool that you have are to go out, sample the stems, and see what you have to work with going into next year. So looking at things from a time perspective, and of course, what I can do now is just get into some of the other areas in the next 15 minutes or so that we've been working on. So Balata Medjugorje continues to work on the remote sensing. You've seen some of his work previously. He's been doing a lot of mapping work, so using the remote sensing sensors that we have, whether it be a red, green, blue camera, a multispectral camera, or LiDAR, to gain an appreciation of what's going on in the field, develop some prescription maps that can be used in the sprayers, in particular with the use of prescription maps to do this. We did have a project that finished up that looked at reducing greenhouse gas emissions. And so I'll just hit the highlights of those. We've talked about those before previously. And so first thing, if you're looking then at means or ways of cutting back on your agrochemical usage, we think the use of the imagery from the sensors is perhaps the easiest way to cut back on agrochemical usage. And then as a result of that, cut back on the greenhouse gas emissions that are occurring as a result of the production practices that are used. More importantly, when you compare what we observed with respect to the greenhouse gas emissions, we did some of this work back in 2004 to 2007. The good news is we continue to have very, very low emissions as far as the greenhouse gases are concerned. As a result of the production practices, we're in a lot better position than most other cropping systems. We have been using quite a few liquid fertilizer treatments over the past few years, and we are seeing that, just given that you apply them, they can get into the root system a little bit more efficiently than a granular fertilizer. They don't seem to be running into problems as much as greenhouse gas emissions are concerned, so they're a little bit lower. There's absolutely no benefit of using some of the nitrifications inhibitors that are used, for example, in some of the cereal-based systems that you see in other production areas. No benefit that we found in this particular study. We are finding some beneficial effects of using some of the nitrogen-fixing bacteria that can be applied to plants in various formulations, whether it be the Invita or the Tricia. but is it really worth bringing in a microbe from another production system to use in our fields? I'm having a little bit of a philosophical problem from that perspective, so it's something that we're continuing to assess carefully. And there's other means of improving the nutrient use uptake and efficiency as well that we get into. And then lastly, before I forget, is when you look then at the blueberry production system, look, it's a net carbon sequesterer. So it's one that, again, one that has potential to use more carbon than what's being generated in its production, but it's not the same as an Acadian forest. Okay, so it doesn't meet the gold standard from that perspective, but nonetheless, it's better than many of the other cropping systems. So it is good news from that perspective, and we're going to continue to work on getting that pulled together and published. So as I mentioned, the liquid fertilizer trials, this is where we have been using the mapping systems. They've worked really well. And just looking at some of the yield data that we had, some of these particular fields, such as those that are up in Earltown, they've always been problematic. We've used them for 2 production cycles, and we had fantastic response this particular season. So by using the particular multispectral sensor, looking then at the nutrient status of the plant, ramping up and down the fertilizer application rates, not applying them to bare areas, we got some yield increases in excess of 50% compared to an untreated control, and then also the granular fertilizer practices that we were using. So really, really nice responses, and this is work that we're going to continue this upcoming year as well. Okay, some other things, fungicide applications, we've been able to get those reduced. And what I want to also mention, just given what we went through this particular season, is once we got into the late July, early August, Ola and I had a meeting, and Ola's sitting in the back row there. I said, Ola, we got to try something with respect to seeing if we couldn't help the crop that was still present in the fields. Past years, and I think we've used anhydesicants, which more or less just apply a film to a plant. Just about every year we've used them, whether it be for drought stress or frost, they haven't worked. But I thought, okay, we have to try it. So we use this product called Parka, and it's one that's distributed by cohort. And what it consists of, which makes it a little bit different compared to these other compounds, is it's a lipid-like material with some other materials situated within it as well. So it doesn't put on as thick of a layer of film onto the plant, but I think it's one that actually worked quite well for us. So we put it out, and the trials were in Mount Tom, and we put them out and really we looked at 3 rates. 1 application, early August, a low and a higher rate, and actually it was a volume of solution that we doubled. And we found that by using this material, especially at the higher rate, which is what the green bar is, we ended up saving about 15% of the crop. And that's the best way to think of it, because at that point in time, there's just incredible amount of drought stress. We applied this lipid-like material. It sealed up a lot of the cracks, crevices on the fruit as well as on the canopy, helped conserve moisture. And then as a result of that, we were able to keep the yields up, whereas otherwise they just continued to diminish as a harvest unfolded. So it is a good news that if we went into this upcoming field season, I'd definitely be looking at the use of this product again. Okay, and here's what the actual application looks like with the large T40 drone. Okay, so that's what's going on as far as that's concerned. And then the one aspect that we do have this year with the UAV system is we've worked with Corteva, and we do have a research authorization for curb applications, so spot sprays using the T40 drone. And so this is work that's going to be going on, and we're going to be using it in combination with a self-propelled sprayer, where we have prescription maps and just blanket applications. So we think, depending on the field, we can really dial back the curb applications that are occurring as a result of this. Okay, so that's what we're seeing as far as those aspects are concerned. All right, so then moving along just briefly into the integrated disease management work we have underway. Just given the complexity of the markets and where the product's going, this is something that we continue to pay careful attention to, not only what's happening within Canada, but in particular within export market destinations such as the European Union. And because of this, provides a really important background drop with respect to, the screening activities that we have underway. And along with that, the work Naomi has been doing is looking at the plant and how they respond, not only to the presence of diseases such as botrytis, but what's it doing to the plant's kind of defense responses, and can we improve this? So this is work that she has underway. She also has looked at extensive screening, not only of our conventional products, but some of the biologicals and some of the biofungicides. And we're also looking at some of the fungicide sensitivity observations that we're seeing as well. So you'll see reference to a lot of the products that we are using right now. And this is work that's ongoing. So overall, we're trying to get a better appreciation of how to use the biofungicides. And then from the perspective of botrytis, get a little better appreciation of, okay, what's the shifts that are occurring? Is this organism that causes botrytis blossom blight, is it becoming more tolerant of the fungicides we're using? So this is work that's underway right now, and we hope to get this finished up in the upcoming months. And then, as I mentioned, also the fungicide resistance aspects, the plant response to the biofungicide, and then also the botrytis work that's going on as well. And then from a sustainability perspective, yes, it's important to look at what consumers can do, what's happening on the processing end, and then also what's happening, while the food item is being distributed. But my reason for being here is to talk about how to produce it and how can we reduce the footprint associated with producing blueberries. And so this is work that's ongoing. What was kind of neat was we were able to start this with an Agriculture Canada project back in 2005. We really couldn't, it's hard to say, why is this production footprint so important back then? But it sure is important now when you look at just what's happening globally with respect to the production of blueberries, like cultivated high bush. They're well over 90% of the global supply of blueberries now. And so really being able to convey an industry as being, the most sustainable out there, I think is going to become really important consideration, but you need the data to back it up. And that's why I'm really fortunate to have a project underway. And then also Emily is working away at that as we speak. So we're interested in looking then at not only what's the footprint perspective from a carbon dioxide, but also the energy. We're also looking at it from perspective of a small grower versus a large farmer operation. And it's really cradle to farm gate is what's being looked at right now. So it's a continuation of what we did in the past. And we're looking at things such as, in particular, the coverage that's present within the fields. So we're continuing to use the drones to document this. We're looking at the various yield components that I've talked about and you've heard me talk about many times before. But again, what we're interested in is being able to convey at the end of this what our production footprint is. And when you look at the nice thing about a lot of the perennial food, particularly the fruit production systems, they have a fairly low footprint compared to some of the other agricultural sectors, in particular some of the red meats. But overall, really, really low footprint. And I think where we're going to end up being is amongst the best, okay, as far as the footprint and the production aspects are concerned. So it's work that we want to be very careful on, and work, as I mentioned, we've done previously where we looked at, okay, what if you take, in this particular case, burning out of the equation with the work that was done in the early 2000s. And then also if we're able to stay away from supplementary irrigation, which is going to be a challenge given what we've went through this past year. But if you take those two things out and you focus on what's left, which is in this particular case, the green, fantastic system. And but we have to update it. Just about 90% of the inputs are using now have come on stream since this initial study was done. So it's something that we want to be careful with. And then the other thing is just given how the pollinator management practices have changed, we want to look then, okay, just given how significant a change this has been, bringing in the honeybees and also bumblebees. What's this doing to your production footprint as well? Because, yes, there's an investiture to get those to the field, but then you're also getting a response, and hopefully a good yield response as a result of bringing these in as well. So it's something that we're going to continue to work away at over the upcoming years. And knowing that time's moving along here, get just a few more minutes. Oh, sorry. Well, thank you. I thought I was down like 3. Okay, so anyway, the sustainability is something that is definitely going to continue to be a really, really important consideration as we work our way through our research and development activities. And as I mentioned, it's Emily that's really leading this up with respect to her work. Also looking at the berry ripening process. At the start of this field season, we were really optimistic. The bloom looked fantastic. And we thought, okay, we might end up being in a scenario where we need to slow that ripening process down. First thing. Second thing, how can we keep the quality of the berry up? And so we have a 4th-year student using this as their honors undergraduate project, looking at means of slowing the ripening down, seeing if we can't get some calcium into the berry, improve its firmness. And this is work that Callie has underway, and she'll be finishing up shortly. And then the last thing I'll just mention is a project that came forward to Bragg Lumber Company last year, and it's just a new product that's undergoing global registration right now by Bayer Crop Science. And it's a herbicide. It's called icofolamethyl, and it's in a new group. The active ingredient is what's referred to as the icofolamethyl. It's been submitted for registration consideration in 4 countries. So Canada, the United States, European Union, and Brazil for funding or for consideration. So we're hoping it'll get registered 2028 or so, maybe a bit. 2028. But what's neat about it is we initially thought it was in the same family as curb. The advantage of it is it's not anywhere near as volatile as curb, so you have a lot more wiggle room, okay, with respect to its application. It is a new chemical class, and Bayer have invested a tremendous amount of resources into its development globally. So over $500 million Canadian has gone into it. And when you look at the blueberry sector, it's really, really small. They're interested in the other major crops. And we've been able just to get in, provide some initial data, show that it doesn't affect the blueberry plants, and it's looking quite good. All right, so it's been more recently classified as a group 23. It's similar in how it works in that it inhibits cell division and microtubular organization. It has some really interesting characteristics associated with it. What makes it unique compared to curb is it has some post-emergence activities as well. And so what they found in some of the cereal crops is it has really good efficacy at quite low application rates. So they are interested in looking at it as a burn down product there. And along with that, when you look at some of the problematic weed species that it controls globally, this is what's been compiled by Bayer Crop Science in Germany, significant list. And on our end, we've been able to just augment it a little bit. But again, our emphasis was to show that it wasn't going to harm the blueberry plant. So we started with 2 trials last year, we continued those this year. We also put out a crop year trial this year, and then we've put out some fall trials with it as well. Looked at it alone as well as in combination with Allium, as an active. And what we found is the nice thing is the fescues, it's lights out for both the hair fescue as well as the red fescue. Very good control of it. Jury's out with respect to some of the broadleafs. We've seen trials like the one out at DeBert where we got good control of the red sorrel, hawkweed. You go to a muscat orbit, not so good. Okay, so we're trying to get our head around that. But the good news is at least the fescues are getting controlled quite well. So this is some of the slides that have been circulated previously. So here we have treated, what it looked like at the end of last year versus untreated control. And this was its progression. It takes quite a while. It takes about a month to really see the herbicide itself come into action. But this is some of the data that Emily compiled. And again, on the far right, you can see the level of fescue control with it is phenomenal. It's quite good. So we're really, really excited about it. And this just gives you insight into what the trials look like. End of last season, untreated, treated. Pretty good. So excellent control. And we even saw a bit of a yield effect this year where, again, where we were able to clean up the fescue grasses. We saw a little bit of an increase in yield associated with it as well. So interesting. And then this spring, it's what the trials look like. So it seems to be holding quite well. And this might be in part due to the allium, and it has quite a long residual associated with it. And moving along, again, we had a Velpar Sinbar check, and we were seeing all kinds of problems associated with it as well. So really, really nice to see this moving along. And this is what we think is going to be the eventual treatment that'll get commercialized. Okay, this combination of the cicafolin with indaziflam, which is the allium, but it's going to take a few years. So what we wanted to do this year, get it out at some more sites, especially in New Brunswick, where they ran into some issues. But we do have it out at 2 sites in PEI, one being at Benny Neighbors, and that trial, Benny had a look at it recently. It looks excellent as well. So it's really, really quite promising. Right, here's some of the photos from DeBert. And on this particular case, here's the division of the treatment. You have some sheep sorrel, some hawkweed in the mix versus where it's been treated. Over in this area, it seemed to suppress it quite nicely. So we're just going to see how that works over the course of the season. But so far, really looks quite promising. So after such a miserable field season, I thought it'd be nice to at least give you some good news. And the nice thing about it compared to some of the other herbicides is as long as you use it with the kind of the protocol that we did, so put it on a little bit earlier than the Velpar, we're not seeing any visible symptoms of injury to the blueberry plants. Couldn't find any effects of whether it be on the photosynthetic rates or dry matter partitioning associated with it. It just seemed to do a really nice job of controlling the fescue grasses. And the package went off, so we're hoping it'll get included in phase 1 registration of this herbicide for use in Canada. It's going to take longer in Maine because they weren't able to get it on the IR4 list as soon as they had hoped. But we're hoping in Canada we'll see a wild blueberry label for it in the next 3 years or so. So we've done our part. We've got the data into the PMRA and also the Pest Management Center that we've been working with Heather Pyle and her group on this. And again, hopefully we can get some good news on that and not have to worry about fescues any longer. So with that, thank you very much. Okay. No questions? That's excellent. I wouldn't want to say that's excellent, but if you do have any questions regarding the drought stress in your buds, feel free to come and talk to me, and we can follow from there.